Hi guys. So today we're going to talk about where this channel came from. Why did I decide to start this channel? I've been thinking about it for 4 or 5 years. I've been thinking about starting a YouTube channel. Lots of things I want to talk about. And I needed to somehow distill it into one concept I can really focus on. And I thought, I got some writing. I'll promote my writing. I'll do that. I'll keep writing. And eventually the two will work together somehow, right? Obviously, I'm not there yet. What happened was I was sitting there watching this video, another YouTuber called Physics Girl. Now, if you know who she is, maybe you've been watching Smarter every day, and she hasn't made some videos in a while because she's been very sick. The concept that I got does come directly from her. It was before she was sick, obviously. So anyway, hope you get better, Physics Girl. I don't actually know her. This isn't really an important part of the story. So she was sitting there doing one of those videos where the producer is asking her questions about some astronomy stuff. And they're talking about the TRAPPIST-1 Star System and the different planets on it. And she's real excited and talking about it. And these are like my favorite videos of hers, is when her producer is interviewing her about something. At some point, the producer asks, what kind of life would develop on one of these planets? And her answer was, I don't know. You should probably ask a science fiction writer. So that's what we're going to do in this video. We're going to answer that question. What would life look like in the TRAPPIST star system? Before we go any further, make sure to click like and subscribe. That way you'll get to see more content like this. Also, to help other people find this content. You can also join my Patreon. There'll be links down below. And a reminder at the end of the video. For now, enjoy the rest of the video. All right, so before we talk about the star system itself, let's talk a little bit about life and how it develops. The only reference we have for how life develops is life on Earth. And we know that life originally developed deep under the ocean, around thermal vents and stuff, and eventually made its way to the surface. And this is probably still an RNA world. You can talk to the biologists, they can argue this one out. When these single-celled organisms reached the surface, they learned how to photosynthesize. Well, they evolved the ability to photosynthesize. And that meant they were taking in energy from the sun. Before that, they were taking energy from inside the Earth, coming out through those thermal vents at the bottom of the ocean. At the surface, they're taking energy from the sun. So in order to have life, the first thing you need is an energy input. It can come from inside the planet. Easily 99.999 whatever percent of the life that we know about here on Earth, our energy input is from the sun. Well, that's a light. It's nighttime. I can't point at the sun at night. It's down there somewhere. Once you start talking about the sun as your energy input, which is crucial for there to be life on the surface. So we talk about life on Mars right now. It has to be on the surface because that's where the energy input's coming from. There is, as far as we can tell, no energy coming from inside the planet. It's a dead world. But if you look at like Europa, where the Fool's Tale takes place, and there's this ocean swishing around, you have an energy input from Jupiter's gravity. You have energy input from the other moons. Europa is kind of squishing back and forth because of that. It's got tides. It's got all that stuff. So there's an energy input. It's also worth talking about timing, because every form of life we know right now has an active cycle and an inactive cycle. So active, obviously for us, that's when we're awake during the day moving around, and our inactive is at night. We rest by sleeping. I mean, I do most of my sleeping during the day. But anyway, when you're talking about those original bacteria, or whatever it was that formed down around those thermal vents, you have a different kind of timing. You have the ocean swishing around because of the moon, the tides and stuff. And you also have the heat coming out in different cycles, getting washed away in different cycles. So it becomes reasonable to think that timing is an important part of evolution. And I think we can definitely say that as more complex life develops, there needs to be some kind of more timing. Atlas Pro guy, he has a video where he talks about these caves that are completely cut off from the surface, completely dark, and he talks about the life that forms in there. But there's a stream of water that runs through it, and there are cycles in the water. So every life form that we know about builds its life cycle around the various events that happen around it. So salmon, when the ocean temperature reaches a certain point, they swim up into fresh water to lay their eggs. Of course, birds migrate depending on the season. They're either heading north or south. Here in central Texas, a lot of the ones that are migrating fly over us. They stop here and visit for a couple of weeks, and then they keep going north. Some of them stay. And then, of course, in the winter, they come flying through again, and we see it. So there's all sorts of different events that can lead to different timing cycles for different organisms, depending on what they need. So the question is, what do you find in the TRAPPIST system on any of the planets? In terms of energy inputs, it's still going to have actual sunlight, but it's different. We'll talk about that in a minute. So let's talk about how the TRAPPIST system is actually set up. I want to say there's 7 planets. They're all so close to the sun that they would all fit inside the orbit of Mercury in our solar system, which if it was a G-type star like we have, they would all be too hot, but it's not. The TRAPPIST star is a red dwarf. So most of the light it puts out is in the infrared spectrum. There's a little bit, but not much, of visible light. So during the day on a TRAPPIST planet, the amount of visible light received is always going to look like it's around dusk. Never gets brighter than that. Also, these 7 planets are tidally locked to their sun. That means, like our moon, there's one side of the planet that's always facing the sun and one side that's always facing away. Now, Mercury is tidal locked to the sun. And one of the things that happens with Mercury, we see this with the moon too. The rotation is caused by the gravity field by the sun. The sun causes the planet to rotate. Earth just kind of spins. Venus just kind of spins. Very slowly, but spins. Same thing with all the other planets. But Mercury, the moon, and several other moons in the solar system are tidally locked. They want to keep moving in a straight line, but then gravity pulls them in, and then the tidal lock kicks in and pulls them back towards the sun. This leads to a wobble effect for the planet. So the planet's going to wobble a little bit. That wobbling is important. That wobbling is regular, it is periodic, it is predictable. Same thing on Mercury, same thing on the moon. And this means that at the terminator on each planet, there is a day and night cycle. Now, if you go on the day side of the terminator, it's always day. You go on the night side, it's always night. The day side, obviously, is going to be much warmer. The night side is going to be much colder. The next major ingredient you need from the planet is going to be a magnetic field. We don't have the ability to detect magnetic fields on exoplanets right now. I don't know if JWST is going to be able to do that. I do know it can look more closely at these planets, measure things that other telescopes can't. So let's assume magnetic field on at least 2 of the planets. Now on Earth, the original round of extremophiles that developed under the ocean didn't really need a timing cycle. They just needed to work. So with that in mind, we could think on one of the TRAPPIST planets that life would develop on the day side first. And maybe they have oceans. Maybe they could develop under the oceans too. Maybe there's some heat coming from the middle of the planet and they could develop there too and then migrate out like it happened on Earth. So maybe that could happen too. They're going to learn photosynthesis at some point, but the light that they're going to use, the TRAPPIST star puts out much stronger light in infrared. So it makes more sense that they would photosynthesize with infrared light. And I have no idea what that would look like, except that it would result in vegetation unlike anything we've seen. So we have green vegetation because in the entire spectrum of the sun, the energy it puts out, in order to moderate how much energy the plants take in, they don't take in the green. Everything else gets taken in through photosynthesis. So the green gets reflected. That's why we have green plants. If you take a star whose peak energy output is in the red band, then the plants would not take in the red, and they would reflect the red while taking in everything else, and you would have red plants on that planet. So it makes sense that on the TRAPPIST planets, you would probably translucent. I don't know if they would even bother developing anything. Like why? Because what they're going to reflect, if anything, is going to be infrared, because that's where the peak power output is for this star. And then you have solar radiation. Now, on Earth, the solar radiation gets kind of spread out over the whole surface because it turns, and the magnetic field, prevents some of it from hitting us. With these tidally locked planets, they don't. So you're going to have a lack of radiation on the night side, and you're going to have an excess amount of radiation on the sun side. The good news is radiation helps drive evolution. It causes mutations in early life forms. which can be a driver of evolution. So we might expect evolution to happen much faster on the day side of the planet than compared to the Terminators, but it might also be more lethargic or much more energetic life. Either way, the balanced life and the more complex life I would expect to develop in the Terminator area. So at this point in the conversation, we have some plants, the single-celled organisms, and some plants are developing. We're assuming water, waiting for JWST to tell us more about these planets. We're assuming atmosphere too. And at this point in the history of these planets, the same thing happened on Earth. All these single-celled organisms developed in a CO2-rich atmosphere. They turned it into an O2-rich atmosphere and then died off, got buried, and became oil. So there's oil in TRAPPIST-1. We need to go there and get the oil. That joke is way too old. If any life form that winds up thriving on the night side isn't going to need eyes. Meanwhile, any life form that thrives on the day side is going to need eyes that can see in infrared, because that's most of the light they've got. Around the Terminator area, you're going to need a balance, like what we have here. We see mostly balance. You go deep enough in the ocean, you'll find eyes that either don't work very well, or they work very well, but only in that environment. Here, if you want a more general purpose eyes like humans, you're going to find them around the Terminator of these planets. As far as hearing, we could expect some hearing. We could expect, if there's a magnetic field, we could expect senses oriented around the magnetic field. There's much heavier gravity, so we can expect the life forms to be more robustly constructed. And there may not be anything flying. No flying insects, because the gravity is too strong. On the night side and around the Terminator, you're going to have life forms that are able to look into the stars. And the first thing they're going to see is one of their other planets, because they're so close and they go so quickly around the sun, and they're in orbital resonance. So for every 8 times around the sun for the inner planet, the next planet out goes around 5 times. And then it's 5 to 3 and then 3 to 2, something like that. And so the first thing they're going to see are the other planets. Now, here on Earth, we have dung beetles that look up at the Milky Way, and they use that to position themselves on the planet, to roll up their pieces of dung and put them in various places. They use that to navigate. So we can see some small insects and various life forms developing similar traits by relying on the planet swinging around behind them. With that said, I suspect that we would see more intelligent life tending to develop on the day side, not all the way in the middle, getting directly beat by the sun, but more out on the edges, close to the Terminator. So at this point, I'm done speculating. I'm done pretending to be a scientist. I'm not a good enough scientist to have gotten this far anyway. So now let's talk about what the intelligent life would look like if it were to develop there. Because of the lack of visible light, language would be largely spoken. Here on Earth, we use body language as a regular part of our conversation. I would anticipate that there wouldn't be a lot of body language here. What we use for body language would be replaced with pitch, with tone. The language itself, words might change based on what pitch you use when you say them. I think the music they would develop, obviously there'd be a lot of rhythm. I think the music would have more than just the 12-tone scale that we have, the Western scale. Other parts of the world have slightly different scales. But I think what we imagine as music would be very different there. They might even put together chords using pitches we don't even recognize as music. They might even develop hearing above or below what we can hear, and therefore they would have music that takes place in those ranges, and we wouldn't even be able to hear it. The Trappist Metallica could whip out a guitar solo we can't even hear. So as far as industrial evolution is concerned, a lot of this depends on the geological processes. Now, if they had to go through the same atmospheric change that Earth did, then they would have fossil fuels. They would have oil and coal and so forth, natural gas and all of that. They would have that in the crust. They would be able to start digging it out. Of course, they could start burning wood. The first steam engines were powered by wood, remember. If the geological processes are limited, or if they didn't have to do the atmosphere change in the first place, there may not be enough fossil fuels to develop a combustion-oriented economy. Not the way ours is. But the good news is they can still harness the heat coming from the sun to make heat engines. I think they can still develop electricity. Development of electricity doesn't require the development of combustion. And at a certain point, they could develop solar panels that work with infrared. We have some research projects running around right now that are working with infrared. They could develop steam power, stationary steam power, by using lenses that point the infrared light or whatever. Maybe not lenses, whatever. They could, heat up the boiler, that way. They could still use the wood that's there, the translucent wood I was talking about. They could also convert tidal forces into electricity. There are major tidal forces on these planets. And if they have oceans, then there's wind farm and tidal farms and so forth. What I'm saying is, I think it's possible if intelligent life developed, they would be able to progress to a civilization much like ours. Now, the power sources would be different. Maybe instead of having independent cars driving down with combustion engines, they would have gone for a wired system where everything's electric. I don't know. They could definitely have hydraulic energy. They could definitely have wind energy and definitely solar energy. And with the fossil fuels developing, they could have all of that. They could write songs about it. They could sing. Whether or not they could explore space is a good question, because on the one hand, when they have sufficient knowledge of chemistry that they can make fuels and rockets and stuff, there is a question of whether or not they would, just because it would be so difficult. But then after experimenting with rockets, we're talking about planets that have much higher gravity than Earth. Much more, so they're going to need much bigger rockets to get out of the gravity well. They may not be able to get out of the gravity well with rockets as we know them. They might have to figure out fission rockets or fusion rockets just to be able to get into orbit. But after they can get into orbit, getting to the next planet is fairly easy because they're all so close together. So if an interplanetary civilization developed in this system, I would expect them to rapidly expand to the other planets. Now, as far as humans settling on these planets, oh boy, I would write this as a horror story. Infrasound is a real thing, and it really affects us. These are sounds we can't hear, but still affect our biological cycles and so forth. You get this feeling of dread with certain sounds. They're studying infrasound for psychological treatments, psychiatric treatments, whatever you want to call it. And for us to grow earth plants on these planets, and based on what we know now, it looks like we should be able to. We would have to introduce artificial day and night cycles, which is fine. So the stories I would write that would take place on these planets, I would write a horror story about some creature from the day side or from the night side making it to the day side. Very difficult to see because it's basically translucent, probably snake-like with some tentacles, like the depression monster on my website. The overall tone would be pretty doomy and gloomy because of the infrasound. And so all the characters would have this overwhelming feeling of dread just all the time while they're getting stalked. I might tell a serial killer who done it, where the infrasound drove someone nuts, and so he went around starting killing people. Maybe a slasher flick. This would also be a good place to put a story where you have some human settlements, and they believe there is no life on this planet, but then it turns out there is a vast underground ecosystem that uses heat from inside the planet to fuel itself, and they want to get rid of these humans. Or maybe they don't understand who the humans are. If I were to explore the indigenous conquest colonial theme, basically telling parts of European colonial stories, but putting them on the TRAPPIST planets instead, I would make the native intelligent life forms shorter, more compact, more robust. They would be much stronger than we are in a much smaller package. I'd probably give them 3 or 4 legs at least, and 2 arms, and I would probably base it on either ants, maybe tarantulas. Have you ever seen a tarantula rear up and rawr, try to scare you? Yeah, I might do that. And I would have the humans enslave them, and I'd probably tell it in the context of a slave revolt. Now, realistically, after everything I've said here, I'm pretty sure there's no life on these planets. If there is, it came from a different solar system and settled in there. But I think we could tell some pretty good stories that take place in the TRAPPIST solar system. Thank you for watching the video. If you made it this far, you definitely need a like and subscribe. Ring the bell if you want to get notifications. And don't forget to join my Patreon. At some point, when people join my Patreon, this wall is going to be filled with names. Obviously, there aren't any right now. YouTube might be suggesting some videos here for you to watch. You could also do that. Have a nice day.